Let's do a problem from your lab assignment, again from section 5.1. It wants us to find the sum of the finite geometric sequence. Sum of the finite geometric sequence, and that's n goes from 0 to 40 of 5 times 2/5 raised to the nth power. So if we take a look at this sum, we write out the first few terms. We notice that the sequence begins with when n is equal to 0. And so when n is equal to 0, our first term here is n is equal to 0. And then the rest of our terms happens when n is equal to 1, begins when n is equal to 1, since we took the 0th term out. So if we take the 0th term out, what is the 0th term? So we have 2/5 to the 0, and that's just equal to 1 times 5. So our first term is 5. Meanwhile, they took this rest of the sum and they put it together here when n starts with 1. When n starts with 1. And then it goes to 2, and then all the way up to 40. So therefore, the next term that comes up is this term over here, 5 times 2/5. And 2/5 raised to the first power is just 2/5. So 5 times 2/5, you can cancel the 5's out and just get 2's. And so the very first term here is 2, and that is called the a sub 1 term. And the common ratio, what they want you to do is they want you to take this term a sub 1 and a sub 2 and make a ratio out of it. So if you were to divide a sub 2 divided by a sub 1, the 5's would cancel out, and one of the 2/5 would cancel out in the denominator, and you would be left with 2/5 in the numerator. So this is just going to be 2 over 5. So that's going to be your ratio R. So now we've identified a sub 0. A sub 0 is the first term. I think this simplifies to 5. A sub 1 simplifies to 2, and then our ratio is equal to 2/5. So that's all the components that's needed here. We want to go to the total number. What is n? The total number of terms in the sequence. Well, this goes all the way up to 40. And so n is equal to 40, but the total number of sequences is 41. So let's check what they mean by this. So n stops at 40, but it started at 0, so that should be 41. Now imagine if you were to type this sequence up. I suppose if we take out our calculator, we have our summation calculator here. We can start with 0 to 40 of this complicated sequence. It's not that complicated. It's 5 times 2/5 raised to the nth power. So we're going to get something like 8.3333, and then there's a 27 here. So we're going to get this number. But let's actually compare that if we use the formula. So s sub 41 is going to be the first term, a sub 0, which we got to be 5. The a sub 1 term, which we found to be 2. And then we have a 1, and then we have 2/5, And then n is equal to 41 in this case because that's the number of terms that we have. And so the power that we want here is 1 less. So this is going to be 40. And then divided by 1 minus 2/5, 1 minus r. Okay, so we can work this out and simplify it. But again, I'm going to use Wolfram alpha. So we have 5 plus 2 times a big fraction. And so in the numerator of the fraction, I need extra parentheses. 1 minus 2/5, close the parentheses, to the 40th power. And so that takes care of the numerator. And then my denominator, I'll put parentheses again. 1 minus 2/5. Close the denominator parentheses and close the big parentheses. And I got 8.333332. So round off to 3 decimal places. Let's just say 8.333. Is that 3? That's 3 decimal places. Okay, so that wasn't far off from our summation here, 8.333. Way later on they get 27, but that's probably because they rounded off their decimals to however many decimal places this is. Okay, so hope that helps.